Thank you very much. Also very warm welcome from my side. So yeah, I hope I will at least give some perspective to the questions that Matt introduced us to, but let's see about that. Yeah, my name is Christian. I'm based in Berlin. Normally work at SAP Signavio and also focus on some knowledge sharing sessions on the side or knowledge sharing in general. But I will quickly introduce what my talk will be about today. If I'm brutally honest, I would have loved to see more of the GopherCon, but I got hit hard a little bit with side effects of a rabies shot I got early this week, so I couldn't in fact do more of the conference, but I'm glad to be here. If I'm brutally honest again, I had a hard time preparing that talk. I could have imagined giving a talk about, okay, we solved a insert generic knowledge-intensive complex task and how we used multi-agents for it. But I thought, okay, how is that original and how can I give some sort of unique perspective to you from the knowledge that I have or from the background that I have. And that's why I want to give a little bit of a different perspective or perspective shift towards, okay, AI agents are solving more and more complex problems. Is the agent even the thing that might be the bottleneck at some point? What are the ecosystems or contexts in which more complex problems are solved in some cases? Yeah, this is what the talk is all about, because I simply saw so many things on, it solved that very complex knowledge-intensive task in which only one person was involved. So it will also, I will project it will also just run my whole company for all I care. It's not always that easy, and this is what the talk is all about. A little bit about myself. I will click like that. I won't click at all. Now it works. Nice. A little bit about myself, a very outdated picture of myself without glasses. As I mentioned, I'm a senior AI developer at SAP Signavio, an area of SAP that focuses on processes and process management, not only SAP, of course, and views are my own as always. But on the side, I also focus on sharing knowledge. We created multiple online courses around AI, focusing, let's say, whole societal impacts and not just, I don't know, the engineering. This is how you do matrix multiplications, etc. But overall, as AI is affecting whole parts of society. And as a fun fact, I think the youngest person that we reached with that one was 9 years old, and the oldest 87, which is quite impressive. So yeah, all for lifelong learning. What will this talk be all about? I will quickly start with agents from a process perspective, talk a little bit about the complexity of the process domain afterwards, then some sort of different thoughts, schools, freedom or control that we kind of learned a little bit more from early on, and then somewhat of a concept that we try to push of framed autonomy, the concepts of agents. So begin with, let's talk about agents. I have to acknowledge I stole that slide from a colleague and I really like it. Preparing that talk, I went a little bit down memory lane, and in fact, agents, I think this was a screenshot I took 2 years and 2 months ago. I think it was May-ish 2023. Agent GPT, you would describe how, I don't know, some of these examples are very easily now solved with the current version of ChatGPT, but back then, no. Come up with a tasty Easter recipe or plan my vacation. Lack of tools by then, lack of access to data, lack of access to APIs, but essentially most of that still stayed the same. So why am I complaining, or what do I get out of most of these conversations? So most of what I see is levels of autonomy. Agents are currently used even while programming, even while solving somewhat of bigger problems. They are always good at freestyling a way to go. Give them a bunch of tools and some sort, maybe slight restrictions, freestyled way to a goal, do it. However, what we also had as a discussion earlier in other talks was maybe just freestyling isn't the most efficient way and also might cost you some energy, some cost, time, etc. If it's just the freestyled way to a goal, imagine a junior person just giving, okay, here are all the tools, the software that you use, just come up with a solution. Hopefully it works. That's maybe not the best version. And this is why the talk should be about, maybe that does work for the freestyled way to go. How can we learn, or what can we do for more restrictive, more different types of processes? Now talking a little bit about the foundations of business processes. I made the goal to only have one definition in this talk, so it will be that one, and I will extend it a little bit. This is a textbook definition of a process, a business process, a series of related activities in an organization to perform or achieve a specific goal. But I think there will be the signature sentence of myself this talk. It is never that easy. And since I know that Germans like beer and like to talk about beer, I would quickly talk about beer. I'm not quite sure who of you, maybe a quick show of hands, are familiar with the beer game or the beer distribution game. Okay, 0%, great. It's a system thinking simulation game brought up by MIT in which different actors in a supply chain have varying degree of information about each other and trade on that information deficit. Let's say, I don't know, I do not know how much demand my customer has. The customer doesn't know how much supply the warehouse has. And through that, let's say, that imbalance of information, an unfavorable state will come up if they trade together, and even things like, okay, bankruptcies or complete shutdowns of the supply chain might happen if you simply don't care about these things and just act of like, I'm the consumer, I will optimize for what I care about. So yeah, it's never that easy. Processes are embedded in a larger systems in which resources, other actors, their goals are also important. So I tried to refine that definition to some extent. We have multiple actors with different interests, sometimes unclear or even unspecific goals. From an AI perspective, especially important, we have huge time delays between actions and responses. Even also from if one were to recall a reinforcement learning background, it's not a Mario Kart in which you have like a couple of controls. It's an enormous action space because you could do an enormous set of things, and you rarely have, let's say, couples of this is what I changed and this is how it affected it, because it might take half a year and 10,000 things happen in between. Sometimes it's also, I have a limited visibility of the different parts of a process or what role I play in that part. Same goes for agents. If we were to use them instead that way, if I just, let's say, optimize that bullshit agent job, yes, it will do that very efficiently, but it might not end to an overall increase. We have shared resources. Of course, the domains are always that complex, sometimes also accidental complexity to some extent. And of course, a lot of process depth in IT systems, because companies, if they grow bigger, they do not start afresh and say, I will just do everything as if I learned it or would do it on a blank piece of paper. Sometimes there are IT systems floating around, processes that just have been doing like that. And if you do that 1,000 times all over the place, it might be quite difficult to manage. Assumptions, because some of that will play around later. Humans will, of course, be still involved in processes. It's not just a bunch of agents running around your company. IT systems are already in place, somewhat restricting what you can also do for good reasons. You already have place in, and also an assumption, potentially different players in the system have all the same access to technical advancements. So it's not, I have the agents, I do everything better, and therefore I have an advancements. If that kind of levels out over time, that's also not necessarily relevant. Finite resources, I cannot spend indefinite amounts of resources, both AI credits and physical resources. And very, very much rooted in reality, changes to processes are costly and very timely. If you don't believe me, please Google some of these examples in which big customers try to change ERP systems. I think like some records were 10 years, $500 million spent, and nothing changed. So yeah, we are talking about a lot of money, a lot of time, and a lot of complexity here. So this is my day-to-day, what fun I have on an AI or data perspective. As I mentioned, if you do not know how your processes are run process discovery. We look at data, event logs, and what is happening in a company to come up with what and how processes are run. You could also bring all the relevant people together, model, and describe and come up together with what you think the process is or what you think it should be. In some industries, it's also very important to show that you know what your processes are looking like, or also care that you have some sort of oversight. Famous examples are banks, for example, that made up customers, did some creative accounting techniques, and ended up being fined and new rules being generated because something was not necessarily governed. famous examples are, for example, know your customer processes, so that you don't make up customers, you don't commit fraud or money laundering, and your money that is spent is not used for terrorism or other specific uses. Now a little bit about the different thought areas, or like areas in that to some extent came out academically. And this is not a made-up picture, it's not AI generated, it's actually Donald Trump holding up a gigantic wallpaper of a process. I think it's about the approval process for government projects, just to highlight, let's say, how things run and how complex things are. Normative modeling, in some sense, is a practice of, okay, we bring a bunch of people together that think they know what the process looks like. We'll do that in an ivory tower manner. We'll just define or come up with what things supposed to look like, or how things are, or how we think things look like, and afterwards we kind of oppress that on an organization, or I don't know, autonomous systems as well, and things like act like that, and everything will be fine. However, reality is different, and translation to agents, if we over-specify, and many of these things are over-specified and also simplified, we restrict the behavior that agents could do. Yes, of course, if an agent were part of such a system of like approval process for a government contract, there are some restrictions, but just relying on these models and this normative modeling is a restriction in and of its own. And also, as I mentioned, we almost always overestimate how much we know about the process, the goals, the intentions, and what is possible. So we might over-restrict agents in that we would use such a tool or such an approach. However, it's not all that bad. There are some companies, as I mentioned before, highly restricted domains in which, for example, I don't know, it's a matter of public record, it's not secret, Goldman Sachs or other banks have huge rule sets for things like, I don't know, I have an entity A with an entity B in a different country trading a specific asset in a specific amount. What rules do kick in? And it's not a bunch, it's hundreds of thousands, if not millions of rules that kick in. So in such occasions, it might make sense to actually use so-called rule execution engines, either decision execution engines or business process execution engines, but they are very difficult to manage and kind of they require a lot of domain expertise that works in highly regulated industries, but in many cases, you don't need hundreds of thousands of strict rules for an HR process about, I don't know, defining goals or career opportunities or approving your vacation, for example. The other side of the stick is we cannot control what is being done. We do not want to be forcitive in a sense of restricting what is possible. Let's just do it and see what happens afterwards, and we will figure out the best path afterwards. This also relates to the nature of AI agents in the current stance that we just say, freestyle your way to a goal. We might at the end think of, okay, what is the best path? We'll pick that up for the future and let it run. That was also done historically on business processes, innate complex systems. We simply let them run, used billions of sequences, so like, I don't know, who did what, when, and a bunch of other attributes, and then let's look and analyze the data. It's never that easy. Related to agents, we could say, okay, again, freestyle your way to a goal, we will look afterwards what worked best, and we'll just take that into the future. However, most of these things are rather a gimmick as an analysis. Academically, there are a couple of abstractions to analyzing such processes. There are DFGs, which are directly follows graphs, or so-called Petri nets, to analyze a process, like what happens after each other. In practice, they're mostly a gimmick because they abstract so much of the process, it's almost criminal. And to actually make it actionable, in many cases, it's more about the domain knowledge. It's more about the 80-20 rule. Like, it's rarely the exploratory look for yourself type of analysis. It's more like we roughly know what is going wrong. We'll do a static analysis, see, I don't know, if 20 of your customers are 1 million euros overdue, maybe ask them to pay their bills and stop looking for the last penny in the details, because processes do not look like this graph, they look like this, and this is even a zoomed out one. And I would really like to maybe talk afterwards to the colleague who mentioned the PhD in decision, or like in hospital or what was mentioned in hospital or clinical systems, because there's actually a hospital process, and you might think, okay, that's very detailed in what is being done here. No, it's in fact not. So from an abstraction perspective, the action surgery, which you might think, okay, one can have thousands of types of surgeries. A surgery is one box in that graph, and it still looks like that, and it's still unsure what to take of that or how to improve it whatsoever. So it's never that easy if we just say, let them roam free, we'll look afterwards. It's not that easy. So why am I now coming to the take of framed autonomy? I think both extremes have their uses in which very restricted industries, yes, use rule engines, very freestyle ways to go. I do it once, all good, just do it like that. But the middle ground is, I think, an important way for us to zoom at. And this is what I quickly wanted to look at: what things we could learn, or how we could enable agents for bigger problems. Imagine you have some sort of an abstract process, you make it 20% faster, all good, I over-optimized that part, maybe I spend a lot of time. However, if bottlenecks are here and here, I don't get, in fact, any sort of improvement. So it's actually, to some extent, for some process important to somewhat know what is the context, what actors are there, what resources are there, and what type of queuing happens in between, in case there's a dependency. So it might, in fact, be not that relevant to over-optimize one part, one little piece of a process with an agent or with multi-agents. Looking at the context and knowing what your place in a puzzle is relevant. Same goes with orders or prescribing and defining things that need to be done. As I mentioned before, yes, you can do that very rigidly and say, this is always how it should be done, do not ever divert from that path. But I think the reality in most cases is a little bit more flexible. In a loan application process, I do not care about many of the things, but still people spend up, okay, this is how it always has to go down. What we now come up with is a little bit more of a flexible notion of so-called process atoms. In a loan application process, I do not care how many emails, how many contacts, what was checked in what order, but at the end, please have the credit check, or your credibility be checked before you are credited a loan, and have it checked that you're an actual person and not made up another colleague of yours who just made up an account to polish your numbers. So the context of process items, we so far over-specified in that we knew, okay, we know how it works best, just do it always like that is too simple, but also too free if we just say whatever freestyle you get, way to go. Some sort of a flexible notion. In some cases, order matters. In others, we do not really care. So a middle ground, I think, is valuable. And from an academic perspective, what we previously had were so-called imperative models. We always said, this is how it's going down. I define everything. Versus declarative, I just say the restrictive rules. A has to follow B. B should never follow C. But that's all I define roughly. So the notion of process atoms, I think, is an interesting thing also to revisit in the context of agents. Here on that slide, I would rather say we don't have a good learning from our domain towards agents. What I mentioned before, these highly restricted industries, they sometimes use so-called boxed expressions. They have diagrams and they have processes, and then in specific parts of the process, they have specific decisions which are fueled by, I don't know, there are requirements to a decision, and there's the decision itself, which is more of a boxed expression, a table with specific rules. Difficult to understand, only applicable in some things, and very stiff and rigid. So for that, I would say, yes, it can be used for some elements, but decisions and flexibility to decisions is also important to be revisited. In some areas, White might also simply think of, I don't know, if I create a lot of applications to something that then another human simply has to oversee and approve again, I don't know, does that make sense? Some flexibility is also in order. Imagine you have a company and say every book order is controlled by someone who has to look at it. Yes, but that's also costing a lot of money, so you might be weighing in, okay, I accept that some people might order Mickey Mouse as a book and I don't actually want that, but it also frees up space with the other person who has human oversight, because yeah, if you want to stay in control, that might also be a relevant factor. One last point before I come to the conclusion. What we also see is, we talked a lot about context. Context and organizations, a lot has been written down. There's a big piece of knowledge, or like there are bigger pieces of knowledge in either centered in people or in documents, knowledge management systems. In many cases, they are simply not used for the right things. So an example, I took that off the internet, a public example of an SOP, a standard operating procedure. I think Cisco gave that out just as an example. I don't know how to use COVID test kits. It's 40 pages. You do that, then this has to be ensured, this has to be ensured. All of these things are there. But my take would simply be, yes, knowledge management becomes ever more relevant, especially in case of more complex problems that we try to solve, because there are some rules, there are some unwritten rules. IT systems or other systems might not even restrict it, but still they are there for a reason. So knowledge on how processes should run is often there, sometimes in people's head. Yeah, encourage them to maybe externalize it so that it can be used. And also the aspect that it's non-democratized, that people always, for example, these modeling initiatives, they are not democratized. People have highly specific skills and know modeling conventions, for example, so many people don't actually use or ever view these diagrams. So yeah, that would be something that is relevant. And one small thing that I worked on, for example, a little bit of a marketing video, I acknowledge that, but we, for example, worked on a tool that is called text-to-process, or AI-assisted process modeling, where you can either enter a picture or a textual description of a process and come up with some representation of it. And in that way, you do not need to be an expert to model a process of what the stencils look like or what this X means, for example. By the way, an XOR operator. But it actually democratized to some extent. Not everyone needs to know exactly the stencils. Not everyone needs to be an expert by that. But externalizing all the knowledge of the people operating in these processes might in fact be relevant. And given that I did not want to wreck my whole weekend over it, I cannot show all the details because I'm still waiting to publish a preprint with TU Munich that we're currently working on a paper around that. But overall, to at least showing some results. So even if you specified very simply what you wanting to do, a diagram comes out, or you can also say just like give me a manufacturing process and also such a diagram comes out as a means to start a conversation about processes, what things might look like and how we should run, or even just start the conversation. So summarizing, I think it makes sense to consider at least different things like the process domain and the agent domain, processes more from a macro level, agents for now at least, be it a human agent or in fact an AI agent as a natural entity or an AI agent coming from like different perspectives. I think both are relevant for different purposes, so there should be consideration of both if you actually want to solve more complex problems. And this is why we came up with a term, or like a term that we would like to use, of framed autonomy. There is some autonomy, however, there is always also some set of rules who dynamically evolve. It's never that static as I showed in the beginning. Hundreds of thousands of rules, just execute them, but it's also never that easy of just do whatever you want. It kind of depends on your context and it has to be operated in that fashion. With that closing out, beyond the hype of AI agents, freestyled way to a goal is only valuable to a few use cases. For coding, of course, maybe for running your logistics process or doing your year's end statement with regards to the tax checks might not be the best option. Working on accessible knowledge and decisions, and why decisions are made like that, very important. I don't know if some of you know of the initiative of Catena X, for example, sharing knowledge about between vendors in a supply chain, quite interesting conceptually as well. Sharing and bridging the focus on just focusing on the individual level or the higher level, let's say with agents and processes. However, I'm at a more engineering-focused conference. Foundations are key. The systems, APIs, meta models, all of that is very important. And of course, if it's a spot process, if it's very text and communication heavy, just go ahead with what is currently possible. But if you want to look a little bit beyond that, maybe take at least one or two thoughts from talk that I gave you today. And with that, thank you very much.